Hello, good evening. Matamando Mwanza, Gabriel, hello. Mapalo Mwanza. Lamuel, Nukol, okay, Lamuel. Vesa, Mudishanya, Poa Musa, hello. Jane Longwe, good evening. Good evening. Okay, so we will be handling static electricity today. Okay. So we haven't had physics in a while. So I know people are excited to have this lesson. Francis, hello. Diana Mwansa, one of our regulars. Chansa Mulomba, hello. Yeah, so when we have 60 people viewing, I think we'll start. And then the others will join us. So good evening. It's going to be a great evening. Beat me here. Chumemo. All right. Okay, we can start. So electricity. So electricity basically has two parts. You're going to do static electricity, and then you're going to do electricity, obviously, that's moving in inverted commas. That's where we're going to have DC circuits. We're going to look at Kirchhoff's laws and the like. So for now, this is an introductory session. We are going to do static electricity. Okay. Andrew, hello. So we can start. We can start. Okay. So basically, you guys know that an atom is neutral. What do we mean when we say an atom is neutral? We basically mean this atom has an equal number. So because it has an equal number of protons and electrons. Okay. So an atom is described as something neutral because it has an equal number of protons and it has an equal number of electrons. Now, for these to be equal and the atom remains neutral, it means to some extent the charges are cancelling out. So if this atom loses or gains any electrons, it will no longer be neutral, it will instead be charged. So if it loses or gains electrons. Now, electrons are the only things that move. So protons are considered to be stagnant and fixed. So only electrons will be moving. Okay. Even when we talk about electric current, this is the flow of electrons because protons are bound. The electrons are the only ones that are free. If you remember how we draw metallic bonding, would have delocalized electrons and so on. So electrons are the ones that are free to move. So if it loses or gains electrons, it becomes charged. Okay. It becomes charged. Okay. So protons, each proton has a specific charge. Each electron has a particular charge. And as we know, protons are positively charged, electrons are negatively charged. By convention, a proton is said to have a charge of 1.6 times 10 to the power 19, and units for charge are coulombs. Okay, so coulombs. Okay, those that went to funny schools would say coulombs. And then those that went to expensive schools would say coulombs. All right, so electrons are going to have the same magnitude. The only difference would be the sign. So this would be 1.6 times 10 to the power negative 19 coulombs as well. So an atom is neutral. If it gains electrons, obviously it is going to be negatively charged. Okay, if it gains electrons, it is going to be negatively charged. If it loses electrons, it's going to be positively charged. And we said charge depends on what you are looking at. Are you looking at protons? Are you looking at electrons? The magnitude of charge is the same, but the sign is what differs. So you have to be careful in questions. Are they talking about protons or are they talking about electrons? Okay. Now, more about charge. About charge. You guys know from grade 7 that like charges repel. Charges repel, and then unlike charges attract. Okay, so like charges repel, unlike charges attract. Now, repulsion and attraction, these are both referring to a force. You understand? That's why I asked you guys to do vectors analytical method, because forces are going to be back, and the same way we handle vectors is how we are going to be handling some of these questions. So more about charges. So like charges repel, and like charges will attract. Okay? And the repulsion and the attraction effects are due to forces. Okay? Now, there are two types of forces. Forces can be contact forces or non-contact forces. Previous page. Oof. Is there anything on the previous page? This is the previous page. We just introduced to say, okay, we're doing static electricity. We are trying to lay the foundation to say an atom is neutral. Okay? If it has equal number of protons and electrons, it remains neutral. If it loses or gains electrons, it becomes charged. Then, the charge is due to the presence of protons or electrons. Protons are positively charged, electrons are negatively charged. And the unit for charge is coulombs, so just represented by C. So you need to master this number. It may be given in an exam, but it's just better if you have an idea what it is. All right. So more about charge. So like charges repel, unlike charges attract. This repulsion or attraction is due to a force. And this is a special force. It is a non-contact force. Okay. So examples of non-contact forces are forces due to magnets and forces due to charges. Contact forces, like when you push your friends and so on. All right. So like charges repel and like charges attract. Now, you can only have attraction or repulsion when you have two particles at least. Okay, so you need to have at least two particles for you to observe any attraction or any repulsion. And this leads us to what we call Coulomb's law. Coulomb's law. Okay, so Coulomb's law states that when you have two objects, two particles, particle 1, this is particle 1, and you have particle 2, P2. These particles are going to be separated by some distance. And if you remember gravitation, this distance is simply referred to as r, because this can rotate around that, this can rotate around that, so just arbitrarily referred to as r. Particle 1 is going to have its own charge. I'm going to call that charge. Now, charge is represented by letter Q, okay? Because these are small particles, we're going to use small letter Q. So this is going to be charge 1. This is going to be charge 2. So it has been found that the force of attraction or repulsion between these two is directly proportional to the product of the magnitude of their charges, and inversely proportional to the square of the separation distance. What do I mean? The force of attraction or repulsion. We don't know whether it is attraction or repulsion because we haven't assigned any charges yet. The force is directly proportional to the product of the charges, so Q1 times Q2. Now, we are from saying that these charges can be negative or they can be positive. So right now we're only interested in the magnitude of these charges. So we have to make sure the magnitude of the force. So we have to make sure that each charge will be put in a modulus bar. So a modulus bar just makes sure everything is positive. So the force is directly proportional to the product of the charges and inversely proportional to the square of the separation distance. So if they ask you to state Coulomb's law, that is how you're going to state it. Okay? Now, previously we discussed that this proportionality sign is replaced with an equal sign and a K. Okay? So this is going to give us F is equal to K Q1 Q2 over R squared, and then these two things are going to be put in modulus bars. So this K is what we call, it's like an electrical constant. So sometimes you may see people put a subscript E, but to just make our working easier, we'll just be writing K. Okay? And I know some of you have jobbed. Some of you have jobbed. Who by any chance knows the value of K? What is the approximate value of K? No need of including units. What is the approximate value of K? What is the approximate value of K? Anyone who has an idea. What is the approximate value of K? Airtime to the first person to comment quickly. What is the approximate value of K? Network is tripping. Ish. Okay. What is the approximate value of K? Okay, so Gift was the first to comment. So K is 8.99 times 10 to the power 9. 8.99 is as good as 9 times 10 to the power 9. We'll talk about units later, okay? So don't worry. What matters is know the calculations and then units will come in later. This is a force, obviously. Just know that the final answer should have units of force. So Gift, remind me so that you get your airtime. So now that you know this equation, we can now do a question. This should be a very short session. You know, if you're not careful, you may overstudy. Okay? You guys are only doing the introductory stuff. So there are just certain basics that you should know and certain questions that you should be able to solve. Network is bad. Ish. Can you hear me? How many can hear me? Can you hear me? Just comment if you can hear me. Can you hear me? Can you get me clearly? Can you hear me? Can you hear me? Okay, good. So, those that can get me, if you have network issues, so get a different SIM card, or try and watch the video later. Okay, so it could just be the time and the like. All right, let's go. So we quickly revise. We are saying when you have two objects, you have this object here, This is going to be object 1 with charge 1, Q1, and object 2 with charge 2, Q2. The distance between them will be defined as R. We said the magnitude of the force between these two is going to be directly proportional to the product of their charges and inversely proportional to the square of the separation distance. So F is equal to K Q1 Q2 divided by R squared. We have to make sure Q1 is positive. We have to make sure Q2 is positive. So we introduce these modulus bars. And then we said K is approximately 8.99 times 10 to the power 9. Now, you know, 8.99 is just as good as 8. So K basically will just take it to be 9 times 10 to the power 9. You'll learn about units later. For now, the only thing that matters is just know that the units for force should be newtons. Okay. So let's do a question. Let's do a question. Question. All right. A hydrogen atom has 1 proton and 1 electron. Okay. Then you're going to say the separation distance is 5.3 times 10 to the power negative 11 meters. Now, it's not always that you be given proper numbers. Sometimes you may be given prefixes. So be familiar with prefixes, especially nano and micro. Okay, so understand these very, very well. Okay, so a hydrogen atom has 1 proton and 1 electron, and the separation distance is 5.3 times 10 to the power negative 11. What is the magnitude of the force of attraction between the two? Okay. So a hydrogen atom has 1 proton and 1 electron, and the separation distance is 5.3 times 10 to the power negative 11. What is the magnitude of the force of attraction between the two? Now, I have a question. Why do you think they have used the word attraction? Like, why are they so sure that there's going to be an attractive force between the proton and the electron? Why are they saying there's going to be an attractive force? Just quickly comment. What makes you think there's going to be an attraction force between an electron and a proton? Why is there going to be an attractive force between the two? Why do you think the two are going to attract? I gave you a rule earlier. Okay, they have opposite charges. Excellent. So they have opposite charges. And remember, we said like charges repel and then unlike charges attract. So let's try and draw an atom of hydrogen. So we're going to have a nucleus and then we're going to have the orbital. So we're going to have, this is going to be our electron and this is going to be our proton. So electron is going to be negatively charged, proton is going to be positively charged. The separation distance between the two is going to be 5.3 times 10 to the power negative 11. So the proton will be attracted to the electron and the electron will equally be attracted to the proton. You get? And those two forces are going to be equal in magnitude. You understand? So all we do is plug in. Now, I want you to notice something. We have not been given the charge of an electron and we've not been given the charge of a proton. As a standard, remember I told you the charge of a proton is going to be positive 1.6 times 10 to the power negative 19 coulombs. And then the charge of an electron is going to be negative 1.6 times 10 to the power negative 19 coulombs. You understand? So all we do is plug this into this formula that we talked about earlier. All right, easy stuff, easy stuff. So we plug in the force of attraction. So force of attraction is going to be K Q1 Q2 divided by R squared, and then we'll put these in modulus bars. Now, to be more specific, I can rewrite this expression as F is equal to K, the charge of an electron, multiplied by the charge of a proton, divided by the square of the separation distance between the two. We'll put everything in modulus bars because the question says what is the magnitude of the charge. So we plug in, we're going to have F is equal to K is roughly 9 times 10 to the power 9, okay? Multiplied by charge of an electron. Now, because we have modulus bars, we are simply going to ignore the signs. So we're going to make everything positive, okay? So electron, I'll just put 1.6 times 10 to the power negative 19. And then proton, I'm still going to put 1.6 times 10 to the power negative 19. These are both positive because the formula has modulus bars. So ideally, this should have been a negative, this should have been a positive, but modulus bars make everything positive. Divide everything by the square of the separation distance. So separation distance was 5.3 times 10 to the power negative 11. And then we square this. Now, some of your calculators may not be able to handle everything at a go. So calculate in bits. Unless you have a calculator like this, okay, that can write numerators and denominators, my advice is do the top part, do the bottom part, and then divide everything individually. Okay, so we can plug in. So this is going to be 9 times 10 to the power 9. Okay, let's use brackets. 9 times 10 to the power 9, okay, times 1.6 times 10 to the power negative 19. If I want, I can just square this, okay, but then let's just write it twice. 1.6 times 10 to the power negative 19. And then everything is being divided by handle each part individually, also capiba. Nice one. So so this is going to be 5.3 times 10 to the power negative 11. And then you square this. Okay. So my answer is, I don't know if you guys can see, 8.2 times 10 to the power negative 8. Okay, so F is equal to 8.2 times 10 to the power negative 8. All right. Okay. So those that are having network issues, this is going to be a very short video. You can rewatch it later. Okay. I don't know the exact part where you got behind, so it means I may have to redo everything. So it will be easier for you to just rewatch everything, but you still catch up, don't worry. So we are done with this part, and then this is a force, so it needs to have units of newtons. Easy stuff. Let's go to the harder stuff now. Okay, the introduction is always easy. Now, it's possible for us to have more than two forces. So, rather, it's possible for us to have more than two particles. We can have more than two particles. Okay, and here's the trick. There is always one particle to focus on. There is always one particle to focus on. For instance, you can be given such a question. They draw an axis for you, and then they tell you there's a particle here, there's a particle there, there's a particle here. And then they tell you maybe to say this is a right-angled triangle. Okay. Now, careful when they say right-angled triangles because they may only give you some distances and you may need to calculate the remaining distances using the Pythagoras theorem. So we're going to have charge 1, we're going to have charge 2, we're going to have charge 3. Now, I've given you a trick to say there is always one particle to focus on. So, they'll say, for instance, let's assume particle 2 is going to be our focus. And then these particles are going to have different charges. They can be positive or they can be negative. Let's assume this is positive. And let's assume this is negative. Let's assume this is positive. So, sketch the forces on Q2 due to Q1 and Q3. Okay, we are setting the foundation for other questions that we're going to start doing soon. You've been given this scenario. Okay, Q2 is your focus, you have Q1 and you have Q3. They are saying, what forces will Q2 experience due to Q1 and Q3? For now, I just want us to do everything. Just make diagrams, then calculations are going to follow so that you all get to understand. So always focus on two things at a go. Focus on the focus and one other charge. Again, the focus and one other charge. So if you look at Q1 and Q2, do you expect that we're going to have an attractive force or we're going to have a repulsive force between Q1 and Q2? Is there going to be an attractive force or a repulsive force? Are we going to have an attractive force or a repulsive force between Q1 and Q2? What do you think will happen? Are we going to have an attractive force or a repulsive force? Okay, there's going to be an attractive force because these two are differently charged. Now, here's a trick. Only draw the force on the charge of interest. Charge of interest. Or rather, the focus. So here I want you to focus on Q2. Q1, yes, will be attracted to Q2, but Q2 will also be attracted to Q1. Now, the arrow should point, we are focusing on Q2, so the arrow should move from Q2 towards or away from the particular force of interest, the particular charge of interest. So Q2 is going to be attracted to Q1, and the attraction is always along the line that connects them. So the attraction from Q2 will be in this direction. Okay, this is the attraction. Okay, you remember, you only draw the forces on the charge of interest. So this force will be attracted to Q1. Now, next, between Q2 and Q3, what do you think will happen? Are we going to have an attractive force or a repulsive force? Are they going to repel or they're going to attract? Q2 and Q3. Q2 and Q3. Are they going to attract or are they going to repel? Okay, so yes, we are going to have a repulsive force between Q2 and Q3. Now, if my focus was Q3, the repulsive force would have, because Q3 would want to go away from Q2. So Q3 will go in this direction. Q2 will want to go away from Q3, so the repulsive force will be along the same line, but away from Q3. Okay, so the repulsive force will be like this, along this line, but away. Please pay attention to these diagrams, because very soon our calculations will be based on these diagrams. Do you see that? So I can call this, maybe, because this force is between Q2 and Q1, I can call this force F12. The order doesn't matter. F12, meaning it is charge 1 and charge 2 that are interesting. Okay, I'll post the link later. I can only post the link when I'm done making the video. So I definitely will post the link. So the force between Q1 and Q2 is going to be labeled F12. The force between Q2 and Q3 can be labeled F23. The order of the numbers doesn't really matter. We are just labeling these subscripts so that you know how to deal with. Now, if you notice, F12 and F23 are acting on the same particle. And anytime you have more than one force acting on the same particle, there's always a resultant. Let me write that point. Anytime you have forces acting on a particle, there is always a resultant. Now, in rare instances, the resultant could actually be 0, okay? Depending on what other information they've given you. So anytime you have, so we have this force going in this direction, this force going in this direction. So there's going to be a resultant force that is as a result of the effects of F23 and F13. Okay. So we have this object, it is being pushed in this direction and it is being pulled in this direction. Obviously, we are going to have, let me label this, F23, F12. Obviously, we are going to have a resultant force due to these two. So to find the resultant force, the best method is the analytical method. To find the resultant force, the best method is the analytical method. So if we were to use the analytical method on this, we have to make sure each angle is, so when we use the analytical method, all angles should be read from where and in what direction. When we use the analytical method, all angles should be read from where and in what direction. When we use the analytical method, where should all angles be read from and in what direction should those angles be read? When we use the analytical method, how do we read angles? From where and in what direction? Okay, x-axis, yes, positive x-axis to be more precise. And you should read them in what way? Because there are two ways of reading angles. You can read them, let me allow people, so counterclockwise. Counterclockwise, to divided at anticlockwise. So, you need to find this angle in an anticlockwise manner from here up to F23. Okay? Then this angle from here up to F12. And then you plug this in that table and the like, blah, 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 you do your calculations. Okay? So let's do a full question so that you get to appreciate these concepts. Okay, here's a very, very, very interesting question. So, these particles are arranged in such a way that they form a triangle. And this triangle, from here to here, this is going to be 0.5 meters. This is 0.5 meters. This is going to be positive. This is going to be negative. This is going to be positive. Okay? Then they tell you that this is 60 degrees, and they tell you that this is 60 degrees. What do we call such a triangle? By the way, they've only given us two angles. What is the third angle, and what do we call this triangle? So grade 7 knowledge still is still relevant, and you may need to apply it still. What do we call this triangle, and what is the third angle? Because sometimes questions would come like this, and then you need to decipher it. Okay, equilateral triangle, excellent. Even if they have not given us the last angle we know this is 60 degrees. Okay, and I want you to notice that you have not been given this side and you've not been given this side. The fact that all the angles are equal also means all the sides are equal. This is an equilateral triangle. So this is also going to be 0.5 meters. This is also going to be 0.5 meters. So everything in red is something I have just plugged in. It was not originally there. You understand? And then they tell us to say Q1 is equal to Q3, which is equal to 5 microcoulombs. So there's this prefix that has appeared. Whenever you see micro, what does it represent? This prefix, this micro, what does it represent? Okay, so Q1 is equal to Q3, which is 5 microcoulombs, and Q2 is going to be 2 microcoulombs. We're not really interested in the charges, like the signs in front, because the formula has a modulus around each charge. Okay, so to power -6, excellent. So these prefixes should be on your fingertips. Okay, let's go. So the question is, calculate the magnitude and direction of the resultant force on Q. Oh, let me label them. This is going to be Q1, this is going to be Q3, this is going to be Q2. So calculate the magnitude and direction of the resultant force on Q2 due to Q1 and Q3. Okay, so before we go to the calculations, you first of all have to draw what we're just from doing. You have to be able to do this. You have to decide, oh, there's an attractive force, and our focus is this charge. So this attractive force will point towards this side. Ah, this is a repulsive force. So this repulsive force will point away. So it's important that you need to be able to do these things. So our focus is going to be Q2. This is going to be our focus. Now, we have two different charges, and they're going to have different effects. And the arrows that will come from Q2 will differ because we have different charges. Okay? If there's a repulsive force, the arrow points away from the focus. If there's an attractive force, the arrow points, the arrow points away. If there is a repulsive force, the arrow points towards the other force that it wants to be attracted towards. So here, between Q2 and Q1, these are similar charges. So the force is going to be a repulsive force. So this force will be along the same line in this direction, like this. And because this force is due to charge 1 and charge 2, I am going to call this force F12. Next, the force between Q2 and Q3. Where are you confused? Where are you confused? They've given us this question, okay? They've given us this question. They only gave you these two angles, and they only gave you one side. Meaning, you needed to find the third angle, and you needed to find these other sides. Remember, the separation distance is important. Okay. So because this is an equilateral triangle, whenever you have two angles being the same, you know, all triangles, the total number of angles, the total of all the angles is going to be 180. We have a 60 and we have a 60, so far this is 120. So a third one, that is going to be 180 minus 120, so the third angle is going to be 60 as well. Because all the angles are the same, it means all the sides are also going to be the same. Remember, the formula is K, Q1, Q2 over R squared. So it is important for us to have the separation distances. Okay. Next, we need to draw arrows on the charge we are focusing on. Okay? On the charge we are focusing on. So they've told us in the question that charge 1 is the same as charge 3, and this is 5 microcoulombs. Then I asked to say, what does micro mean? And people answered to say this is times 10 to the power negative 6. Next, I started doing these arrows. The arrow can point like away from this charge, or it can point towards a particular charge, depending on whether they are attracting or repelling. So this is 5 microcoulombs. So this is micro, 5 microcoulombs. This is basically a prefix. Okay, so micro is a prefix. The way we have kilo, milli, mega, tera, femto, atto, such. Okay, so the question is saying, calculate the magnitude and direction of the resultant force on Q2 due to Q1 and Q3. Yes. No, not M. Micro, that's the symbol that we use. That's the symbol that we use. Okay. Hopefully you guys have understood. So calculate the magnitude and direction of the resultant force on Q2. Meaning Q2 is our focus. Okay. On Q2 due to Q1 and Q3. Now, before I drew this arrow, I asked myself to say, okay, between Q2 and Q3, are we going to have an attractive force or a repulsive force? These are like charges, so obviously they are going to repel. And if they repel, it means the arrow for Q1 should actually point in this direction, and the arrow for Q2 should point in this direction. Now, only include the arrows on the charge of interest. So this arrow is going to point in this direction, away, because it wants to go in this direction. It is being repelled away from this one. And I'm going to name this force F12, because this force is due to charge 1 and charge 2. Next, there's going to be a force between Q2 and Q3. Was the micro given? Yes, it was given. All this is part of the equation. Okay, all this is part of the equation. So Q2 and Q3, this is going to be, these two are going to attract. Now, if this was a repulsive force, it would have pointed in this direction. You get? But because it is an attractive force, it is going to point towards the charge of interest. So this other force is going to be in this direction. And because this force is between charge 2 and charge 3, I'm going to label it as F23. You get? F23. Okay. Are we together up to this stage? All that I've done is decide, is this an attractive force or a repulsive force? Depending on the nature of the force, they either repel or attract, and the arrows move in a certain way. Okay. Next, read each angle from the positive x-axis and do calculations. So first of all, let's calculate F12, and then we calculate F23. After calculating that, we plug them in, and then we use the analytical method. Then use the analytical method. Okay. So F12, F12 is going to be K Q1 times Q2 divided by R squared. Okay. F23, this is an attractive force, so it will point towards what it is being attracted to. Yeah. Okay, let's go. Time. So let's go. K is 9 times 10 to the power 9. Q1. Okay, I'm going to put modulus bars. Q1, we were told in the question that yeah, we were told in the question that Q1 is 5 microcoulombs. Now, replace the micro with the appropriate figures. So this is going to be 5 times 10 to the power negative 6 coulombs times Q2. We need to multiply Q1 and Q2. So Q2 is 2 microcoulombs. So this is going to be 2 times 10 to the power negative 6. So the micro just tells you it's times 10 to the power negative 6 divided by. I want you to notice that you are calculating F12. And the separation distance was not given. You needed to get the separation distance from your understanding that this is an equilateral triangle. So separation distance is 0.5. So everything here is going to be divided by 0.5. Don't forget to square the separation distance. Now all you do is plug this in your calculator. Easy stuff. Okay, so this is going to be 9 times 10 to the power 9 times 5 times 10 to the power negative 6 times 2 times 10 to the power negative 6. Everything divided by 0.5 squared. Okay, so this I have found F12. I have found F12 to be 0.36. This is a force, so units are going to be newtons. We found F12. Okay, next we calculate F23. F23. So F23 is going to be K Q2 times Q3 divided by R squared. So it's going to be K is 9 times 10 to the power 9. And then Q2, Q1, Q2, these were given here. They were given. Okay, so we want 2 and 3. 2 is 2 microcoulombs. So this is going to be 2 times 10 to the power negative 6. And then 3. 3 is going to be 5 microcoulombs. So this is going to be times 5 times 10 to the power negative 6 divided by 0.5 squared. If you look at these things properly, you notice that it's the same digits. So basically F23 is also going to be 0.36 newtons. You see that? So we know F12 is 0.36 newtons, F23 is 0.36. Now, they don't want the individual forces. They want the resultant force. Because it's like there's this force, there's this particle here, is being pulled in this direction, at the same time it's being pulled in this direction. Where is it going to go? There's always going to be a resultant whenever you have quite a number of forces acting on a particle. How do we get that resultant? We get that resultant by using the analytical method. Okay. So let's just sketch everything properly. So this is F12, this is F23, okay? And we know this came from a triangle. This came from a triangle that had this angle at 60 degrees. It had this angle at 60 degrees, meaning this angle is also going to be 60 degrees. You see that? Now, if this angle is 60 degrees and this angle is 60 degrees, if you look at this, this is a straight line, okay? This is going to be a straight line. And if this is a straight line, then the total angle here is going to be 120 degrees. Okay. Now, you want the answer? Let's calculate together. Now, for us to do these calculations, each and every force has to have its angle being read from the positive x-axis. You see that? From the positive x-axis. Now, because this is an equilateral triangle, it means this 60 degrees here is being divided equally. This is going to be 30. This is also going to be 30 degrees. You see that? I hope you guys are following. This is going to be 30 degrees. This is going to be 30 degrees. Okay? Meaning, this other line is also going to divide the 120 equally. You see that? So on top, we're going to have 60. Below, we are also going to have 60 degrees. I hope you guys are understanding this. The symmetry of the triangle is going to help us divide these angles. So let me just start. Let me start. This is F12. This is F23. This came from an equilateral triangle. Okay? Equilateral triangle, this is 60 degrees. This is also going to be 60 degrees. If this is 60 degrees, then the total here is also going to be 60 degrees. I hope you guys are getting that. Now, for us to use the analytical method, we need to bring in an axis so that all the angles can be read from the positive x-axis in an anticlockwise manner. So this axis is going to be introduced here. You see that? Now, there's something special about this line that we've drawn. This is the y-axis. The y-axis, because this is an equilateral triangle, it is going to divide this angle into two parts. You see that? Meaning, this angle here is going to be 30 degrees. This angle here is also going to be 30 degrees. You get? Another division is the x-axis here. The total angle here, the total angle between F12 and F23, we found it to be 120. How did we arrive at 120? We had such. We've been told this is 60 degrees, so this should be 60 plus this should give us 180. So this should be 120. 60 plus 120 should give us 180 because this is a straight line. Now, we have a line that is dividing this into two parts, and we have another line that is going to divide this into two parts. Okay. All right. So, if this angle here is going to be 30 degrees, and I know this is a right-angled triangle, then this is going to be 60 degrees, which makes sense. Remember, we are saying this 120 has been divided into two parts. So this is going to be 60 degrees. So we've used two methods to prove that this is going to be 60 degrees. Okay. So this is going to be 60 degrees. If this is 60 degrees, this other one is also going to be 60 degrees, because if this is 30 here, then this on top should also be 30. Key thing that I'm trying to drive at is this is going to be F12, this is going to be F23, and this angle here is going to be 60 degrees, this angle here is going to be 60 degrees. That's the key thing. And this 60 degrees came from the fact that the triangle we're dealing with was, or rather is, an equilateral triangle. Next thing that we're going to do is we have to make sure you can calculate Q1 and Q2 correctly, in that the charges are equal. What do you mean? What do you mean? What do you mean? Okay, I don't really get what you mean. All right, let's go. The angle for F12 read from the positive x-axis is going to be this. This is the angle for F12. The angle for F23 should come here, should start here and end where F23 is. Okay, so I need to know what the first angle is and I need to know what the second angle is. So F12 has an angle of 60 degrees from the positive x-axis. Okay, F23, you know, this is a full circle and we have a 60 degrees here, meaning the angle for F23 is going to be 300 degrees. It is important that your angles are read from the positive x-axis if you're going to use the analytical method. Okay, because for the analytical method, it relies heavily on the angles because the concept, your calculator follows quadrants, so you have to use correct angles. So we are going to now draw a table for F12 and for F23. Okay, so remember the analytical method is going to have vector, we're going to have the x component, we're going to have the y component. Okay, so we are talking about two vectors here. We are talking about vector 1, which is f1, 2, and vector 2, which is f2, 3, and obviously we're going to have a resultant. Okay, so that's that. Now, f1, 2, we calculated it to be, what did we find f1, 2 to be? This was 0.36 newtons. The f2, 3 was also 0.36 newtons. Now, the next thing is I need to plug in the correct angles. What's the angle for f1, 2? What's the angle for f2, 3? f1, 2, the angle was 60 degrees. f2, 3, the angle is 300 degrees. We want the resultant. This is the x component of the resultant. This is the y component of the resultant. We can label this as Rx. This can be Ry. Okay. So x component, all x components. Now I'm going to ask this question. X components, do they have cos or do they have sine? What do the x components have, cos or sine? What do the x components have? Cos or sine? What do the x components have, cos or sine? Okay, so all the x components are going to have cos. So this is going to be 0.36 cos 60. This is going to be 0.36 sine 60. Okay. Then we'll calculate. Here, we're going to have 0.36 cos 300. This is going to be 0.36 sine 300. Okay. Then we do the calculations. Cos 60, you know, is half. You guys are experts at this. Let's just use a calculator. So 0.36, I hope this is visible. So 0.36 cos 60. Make sure your calculator is in degrees. Okay, so answer is 0.18. So 0.18. And obviously everything here is in newtons. Next, 0.36 cos 300. 0.36 cos 300. Okay, this is also going to be 0.18. As you know, cos is positive in the fourth quadrant. Yeah, we do the same for sine. 0.36 sine 60. Okay, this gives us 0.312. 0.312. Okay, we do the same for sine here. 0.36 sine 300. We should expect a negative answer because in the fourth quadrant sine is going to be negative. Okay, so negative 9 what. So if it gives you this funny answer, you press this button SD. Okay, SD. So this gives us negative 0.312. Okay, then we're going to add everything in the x, we're going to add everything in the y. So Rx here is going to be the sum of these two. So 0.18 plus 0.18 is going to give us 0.36. Okay, then here we have positive and we have negative. If we add these are going to give us 0. Okay, so the resultant, the actual resultant. Remember, R is equal to square root of Rx squared plus Ry squared. Okay, so plug in R is equal to 0.36 squared plus 0 squared, and then you square root. Obviously, your R is just going to be 0.36 newtons. Okay. Now, the question said, find the magnitude and direction. So this is the magnitude of R. For the direction of R, we need to sketch the components. So for the direction, sketch Rx and Ry. So if we're to sketch Rx and Ry, Ry is 0, so there's no movement in the y. Rx is 0.36 and it is positive. So the only thing we have is this. Okay, so for the direction, you can already tell this is in the x-axis. What angle do we give to the x-axis? Quickly comment. What angle do we give to the x-axis? What angle do we give to the x-axis? What is our theta? What is our theta? What angle do we give to the x-axis? Quickly. Okay, 0 degrees, yes. Yeah. So, the full form of the answer can be the resultant is 0.36 newtons along the positive x-axis. Okay, yeah, you are done. You are done. So that's how these questions can come. The other question that you guys should be able to solve is this type. Pay attention. Okay, so quickly we end this session. So you've been taught 3 charges are oriented along 360 could also be correct, but it is overcorrect. I don't know if you get it. You want the smallest possible angle representing that angle. So they would still mark you. Believe you me. Now, data and data. Okay, let's go. So 3 charges are oriented along the x-axis. Okay, comma. Q1 is at the origin and Q2 is 2 meters and Q2 is 2 meters from the origin along the x-axis. Okay, pay attention to this question. 3 charges are oriented along the x-axis. Q1 is at the origin and Q2 is 2 meters from the origin along the x-axis. Notice this is positive 2, right? Because from the origin you can either move to a negative side or to a positive side. Okay. Then we are going to say if Q1 is equal to 7 microcoulombs and Q2 is equal to 21 microcoulombs, where should a third charge Q3 be placed? Okay, with respect to the origin. Now, there's one other thing I'm supposed to include here. Q1 is going to be positive. Sorry. 3 charges are oriented along blah 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 blah. Where should a third negative charge? Okay, so add the word negative. It's important. Where should a third negative charge Q3 be placed with respect to the origin? So for these questions, you can you will be required to do your own sketch. You may be required to do your own sketch, or a sketch can be provided for you. So it's easier for you guys to handle questions where the sketch has been provided if you have ideas about questions where you need to do your own sketch. So we do the sketch. I'm a screenshot, copy and fast. Let's go. So pointers. So the first pointer is going to be sketch. Now, we are going to make our own axis. The special thing is that everything is along the x-axis. This is our origin here. Okay, they've told us there's Q1 at the origin. We have Q1 at the origin, and then we have Q2 2 meters from the origin. So Q2 is going to be here, Q2. And notice there was no sign in front of Q1 and there was no sign in front of Q2, but they emphasized that Q3 was negative. You get? Meaning Q1 should be positive and Q2 should be positive. So I'll put a plus sign where Q1 is, and I'll put a plus sign where Q2 is. They are asking us where a third charge should be placed with respect to the origin for it to experience no net force. So they're asking where should a third charge be placed so that it doesn't experience any force. Now, this is actually an equilibrium type of question, okay? The third charge should be at equilibrium. Now, if these two charges are positive and the third charge is negative, it means, so let's just place it anywhere. I can either draw it here, I can draw it in the middle, I can draw it there. Okay, it doesn't matter where you put it. This is just a sketch. So let's assume I decide to put the third charge here. And we've said the third charge is negative. And I want you to pay attention to something. We have not been given the charge of the third charge. And it's for a reason. You're going to see very soon. Now, this third charge is going to be Q3. Q3 is going to experience two attraction forces. It's going to be attracted to Q1 and it's going to be attracted to Q2. So this attraction force, I'll draw it this way. This other attraction force, I'll draw it this way. Since you guys are already familiar with subscripts, I can call this attraction force F23. I can call, can't see clearly. I can call this attraction force F23. I can call this attraction force F13. Okay. Now, for Q3 to be at equilibrium, what do you think should be the relationship between F13 and F23 for Q3 to be at equilibrium? What do you think should be the relationship between F13 and F23 for Q3 to be at equilibrium? Like for Q3 to remain where it is. Because if we didn't have Q2, this would be attracted towards this and it would move. If we didn't have Q1, this would be attracted towards this and it would move. So for it to stay where it is, what should be the relationship between F13 and F23? What should be the relationship? Indeed. F13 should be equal to F23. Easy stuff. F13 should be equal to F23. You understand? Let's go. There's one other important aspect. They told us that the distance from Q1 up to Q2 is 2 meters. Okay? Now, these 2 meters needs to be divided because I'm interested in the distance from Q1 to Q3 and the distance from Q3 to Q2. So here's a pointer. The first distance is x, okay? The first distance is always x, and then the remaining distance is 2 minus x. So other distance is 2 minus x. I think we've done such a question before, so you guys should have ideas. So this distance, okay, maybe let me just redraw this. Okay, we can use the same one. The total is 2. This 2 can be divided into 2 parts, okay? This distance from here, let me use blue. from here up to here is going to be labeled x, and the distance from here up to here is going to be labeled 2 minus x. When you add the two distances, they need to give you 2. Okay, so let's try that. X plus 2 minus x. Then the x's will cancel out. I'll be left with 2. Remember, we said that the two distances should add up to give you 2. The first distance is always x. The second distance is always 2 minus x. If the total distance was 10, the first one would have been x. This would have been 10 minus x. You get? Let's go. Let us go. Now, this is our diagram. This distance, we are calling it x. This distance, we are calling it 2 minus x. This is Q1, this is Q2, this is Q3. Q1 is positive, Q2 is positive, Q3 is negative. Okay? So there's an attractive force in this direction, there's an attractive force in this direction. I'm calling this attractive force F23, this other attractive force F13. Okay? And we've said F13 should be equal to F23. Okay? Now, let me find the F13 alone. F13. F13 is going to be equal to K Q1 Q3 divided by R squared. Now, I want you to pay attention to the fact that Q3 was not given. So Q3 was not given because it is going to cancel out at some point. You're going to see. Now, Q1, we were told Q1 was 7 microcoulombs. 7 microcoulombs. We were told Q2 was 21 microcoulombs. 21 microcoulombs. So we can plug in. I'll put modulus bars because I'm not really interested in the signs, just the magnitude. This is going to be F13 is equal to K. Okay, I won't even substitute K. The only thing that I'm going to substitute here is going to be Q1. So this is going to be K multiplied by 7 times 10 to the power negative 6. And then I'm going to put Q3. Okay, divided by the separation distance between Q1 and Q3 is going to be x. Don't forget that the separation distance should be squared. This is the first expression. Okay? Second expression, this is going to be for F23. F23 is going to be K. You're going to see why I have not substituted K and why I have not replaced K with its value. And you're going to understand why in the question they didn't bother giving you the charge of Q3. So K, F23, that is going to be 21 times 10 to the power negative 6. Okay? Close, and then this is going to be Q3. Yeah, Q3 divided by the separation distance between Q3 and Q2 is going to be 2 minus x. Careful, 2 minus x. This should be squared. Okay. So, this is going to be expression 2. Now, for this thing to remain at equilibrium, F13 should be equal to F23. Remember, we said F13 should be equal to F23, meaning K 7 times 10 to the power negative 6, Q3 divided by x squared should be equal to K 21 times 10 to the power negative 6, Q3 divided by 2 minus x squared. If you look at these expressions, you notice that the K can cancel out, and you're going to understand why the Q3 was not given, because it cancels out. All they want is, at what distance should Q3 be put? So all you want to calculate here is the value of x. Easy stuff. So you're going to be left with 7 times 10 to the power negative 6 divided by x squared is equal to 21 times 10 to the power negative 6 divided by 2 minus x squared. Easy stuff. Okay. And then you expand this. This is basically a quadratic expression. Okay, so this is going to be 7 times 10 to the power negative 6 multiplied by 2 minus x squared is equal to 21 times 10 to the power negative 6 multiplied by x squared. Now, if you look at this and that, there's a number that can go into these two. I can divide this side by 7 times 10 to the power negative 6. I can divide this side by 7 times 10 to the power negative 6. This cancels out. I'm left with 2 minus x squared is equal to, these cancel out. 7 into 21 will give us 3. This is going to be 3x squared. Okay, and then you expand this. This is going to be 2 multiplied by 2 minus x multiplied by 2 minus x is equal to 3x squared. This is going to give us 4 minus 2x plus x squared is equal to 3x squared. You get? Yeah, so this is going to give us 4 minus 4x plus x squared. These 3 can be made to cross, minus 3x squared is equal to 0. Okay. All right. So 1 minus 3 is going to give us negative 2. This is going to be 4 minus 4x minus 2x squared is equal to 0. So writing it properly, this is going to be negative 2x squared minus 4x plus 4 is equal to 0. If you want, you can divide everything through by 2. Yeah. So let's do this. Let's do this. Yeah. And then you can solve this quadratically. So try and you can submit your answers. Submit your answers. Okay. That is where tonight's session ends. We are going to have another session at 22 for calculus. Okay. So please, for those that joined in late, rewatch the video, make sure you understand each and every part. Because all these basics that I've given you, as silly and as obvious as they look, are the foundation for the parts that are going to follow. Otherwise, we are going to have another session. It will be communicated in the group. Have a good night. We'll see you at 22 again.